Ohm's law, we need certain components. That's first the source of E.M.F. We talked about it. The second is the current, and then the third is the resistance. We are going to tackle the resistance first. We have to be able to calculate the resistance. Why do we need resistors? Resistors are components that help to limit or regulate the motion of electrons through a substance. Now, if the resistor is well calculated with relation to the source of the E.M.F, then we can know the current that we will generate or the current that we will produce. Therefore, it is important to calculate for a resistance. Resistors are coded with colors for easy identification. Okay, for easy identification, as soon as one takes a resistor, the person should be able to tell the type of resistor and the value of the resistor. In view of that, you have to learn how to calculate for resistors, even though we may not be having a multimeter. All right, so let's go. We have the code is 1, there is 2, 3, 4, 5, 6, 7, 8, and 9. The gold represents the tolerance level, which is 5%, and then the silver 10%. We are going to do that calculation. Assuming we have a resistor, which is of this nature, a resistor normally has three color belts and then one at the extreme. So let's take one belt, 2, 3, and then uh, tolerance. So should we say the first color, let's take brown, then the second one should be black, and then the next one should be orange. Then let's take this to be gold. Okay, what it means is that when we see the first color, we just write it down, which is brown. So brown is 1. We just write 1 down. The next color is black. We write the value there, which is 0. Then the next one, which is the third color, represents the number of zeros that will be added to these two digits. So orange is 3, meaning we need 3 zeros. So we add 1, 2, 3. Then we will calculate for the tolerance. Okay, tolerance means 5% of 5% of this value. Either we add 5% or we subtract 5% of this value. So we have minus 5% of 10,000 and then plus 5% of 10,000. Let's note also that 1,000 is a kilo. So as this is 10,000 ohm, right? We cannot say this is 10 kilo ohm. 10 kilo ohm. Now that we have been able to calculate for resistance, we are going to apply resistance in Ohm's law. Okay, we are going to relate resistance to Ohm's law. Practically, let's take a question. Should we have an E.M.F of 12 volts, all right, and a resistance of 2 kilo ohm, a resistance of 2 kilo ohm, and then we are supposed to find the current that flows through the circuit. If I want to draw this, it means that I have a source of power, okay, which is 12 volts, right? And then I have a resistor which is 2 kilo ohm. Now my duty here is to calculate the current that will move through this circuit. What current is the 12 volt driving through the resistor in the circuit? That is what you are going to do. So quickly, we refer to Ohm's law, which says that V or E.M.F equal to current times the resistance. Right? By simple algebra, we can say current is equal to voltage over the resistance. Current will become, the voltage is 12 volts, then the current, the resistance is 2 kilo ohm, whereby kilo is 1,000. So 2 times 1,000 ohm. By calculation, I can say current is equal to 6 on 1,000 V ohm. So we can say current is equal to 6 times 1 over 1,000 amp. You know, current is measured in amps. So this will be equal to 6 milliamp, whereby 1 over 1,000 is a milli. So we have 6 milliamp. This is the current. So we say 6 milliamps of current is flowing through the circuit, and this is in the resistor as well. So with this, let's try a different example. So let's try the next example and find how to calculate for voltage when we are giving current and resistance. So assuming we have a current of 20 milliamp, all right, and then we have a resistor of 100 ohm. The question is, let's find the voltage or the potential difference in the circuit. Let's not forget the word uh, voltage or E.M.F, which is electromotive force, and then potential difference may be used interchangeably. But potential difference is when there's a closed circuit for current to flow, and then E.M.F is electromotive force, whereby there's no connection, whereby there's nothing connected to the terminals of the source of voltage. So let's do that. Quickly, we write the Ohm's law down. We are looking for voltage. So we say P equal to 20 milliamp times 100 ohm. 20 milliamp times 100 ohm. Initially, we know that milli is out of thousand. 1 out of 1,000. Milli is 1 out of 1,000. So V equal to 20 divided by 1,000 amp times 100 ohm. By cancellation, we will see that the voltage is 2 volts. 2 volts. 2 volts.